Alright, so we had this problem that came up. Was asked to do 8.3 number 5 and then 8.4, 49, 53, and 65. Okay, so on 8.5 number 3, the question reads, Francois shoots a basketball at an angle of 48 degrees from the horizontal. It leaves his hand 7 feet from the ground with a velocity of 21 feet per second. Construct a set of parametric equations describing the shot. That's what I started doing here. X of t, that's a horizontal position, would be the initial velocity times cosine of 48 degrees times t. So it's cosine because we want this side. And then y of t is negative 1/2 at squared plus v naught sine 48 degrees times t plus h naught. H naught is the initial height, and that's 7 feet, and v naught again is the same initial speed, but doing sine 48 gives us the vertical component there. Now this function here, it's the standard position function for things that are falling. And this counts as something falling. Okay, so let's continue. So our x of t is going to be, let's see here, 21 times cosine of 48 degrees times t, and that's what? .05t. That describes the horizontal position. Y of t is going to be negative 1/2. In terms of feet, acceleration is 32 feet per second squared, so 32 times t squared plus, that's going to be 21 times sine of 48 degrees t plus 7, so that's going to be what? Negative 16t squared plus 21 times sine of 48. That's going to be 15.61 t plus 7. Okay, and that describes, these two equations describe the position, the vertical position, the horizontal position. And I've already kind of sketched the path of the ball. It's going to go up and come down. The last part of the question is, will it make the basket? Is it going to make the basket? Well, let's see here. C, the basket is located at x equals 15 and y equals 11. So whenever it's 15 feet away, will it be 11 feet high? So we'll find the time when it's 15 feet away. So 15 equals 14.05 t. We divide both sides by 14.05. T would be equal to 15 divided by 14.05. I get 1.068 seconds. I know I have an issue with significant figures here, but I'm going to go with it anyway. So y of 1.068 is going to be negative 16 times 1.068 squared plus 15.61 times 1.068 plus 7. So it's negative 16 times 1.068 squared. Doing the calculator work now. Plus 15.61 times 1.068 plus 7. And that means that this comes out to be 5. Oh, it's messing with me here. 5.42 feet. That's the height. So we're clearly below the 11 feet we need to be. We're actually less than half the height. So yeah, he's going to miss. It's going to come down here, and we're going to be at half the height when we're at 15 feet. So this is going to come out to be 5.4 feet. And that's not going to make it. So that's the first problem. That's 8.3 that was asked. Okay, or 8.3 number 5. Now we have 8.4 number 49. Okay, for this one, we're using that z1 is going to be the magnitude of z times cosine of theta 1 plus I sine of theta 1. And z2 will be magnitude of z2 times cosine of theta 2 plus I sine of theta 2. So the question is, now this says trigonometric and standard form. Okay, so this puts it in trigonometric form. Okay, so for z1, which is negative I, if you were to graph that, where is that? That's just down here. Okay. So our theta, I mean, we can go through and do this, that tangent theta is going to be negative 1 over 0, but that's undefined. We can use our experience and our logic to know, okay, well, theta is 3 pi over 2. As far as the magnitude of z1, that's just going to be the square root of 0 squared plus negative 1 squared, square root of 0 plus 1, square root of 1, which is 1. So our z1 would be just written as 1 times the quantity cosine of theta, or sorry, cosine of 3 pi over 2, plus I sine of 3 pi over 2. And by the way, sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0, so it's basically just 1 times the quantity 0 plus 1 times negative 1. Now, our z2 is going to be 1 plus I. If we were to graph that, that means here's 1 and there's 1. We're right up here. You can probably guess what the theta is going to be. Tangent theta is going to be the coefficient for I, which is 1, over the A, which is going to be 1. So tangent theta is 1. Means theta is arctangent of 1, which is pi over 4. The magnitude of z2 is going to be the square root of 1 squared plus 1 squared, square root of 1 plus 1, square root of 2. So our z2 is going to be the square root of 2 times cosine of pi over 4 plus I sine of pi over 4. Now we're doing division. And the division, I get this from the book, also from my notes, but from the book it says z1 over z2 is going to be the magnitude of z1 divided by the magnitude of z2 times cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. So in this case it's going to be 1 over the square root of 2. The magnitude of z1 is 1, magnitude of z2 is square root of 2, times cosine of 3 pi over 2 minus pi over 4 plus I sine of 3 pi over 2 minus pi over 4. And that's let's rationalize the denominator. It's not rationalized. Z1 over Z2 is going to be the square root of 2 over 2, just rationalizing that denominator, times what now? Cosine 3 pi over 2, that's 6 pi over 4. 6 minus 1 is 5, so it's cosine of 5 pi over 4 plus I sine of 5 pi over 4. And that's going to be the square root of 2 over 2 times what? Now cosine of 5 pi over 4, just think about the quadrant there. This is pi over 4, 3 pi over 4, 5 pi over 4 is there. So sine and cosine are both negative. So cosine of 5 pi over 4 is square root of 2 over 2, negative, plus negative square root of 2 over 2, because sine's negative there as well, times I. So we have square root of 2 over 2 times negative square root of 2 over 2 gives us negative 2 over 4 minus negative 2 over 4 I, or should I say plus the negative. So that's going to be negative 1/2 minus 1/2 I. And this would be that answer. Okay, I just checked the book. The book, it's the same answer, but they say negative 3 pi over 4. That just is going back this direction, is negative 3 pi over 4. But I like to go that way, whatever. And they did not rationalize the denominator. So let's go on to the next thing, which I believe was 53. Yep. So for 53, we have, it says plot both complex numbers on the same graph and plot their product. So we have 4 times cosine of 5 pi over 6 plus I sine 5 pi over 6, and then times 2 times the quantity cosine of pi plus I sine of pi. Okay. So let's go ahead and graph this. If it helps, we can look at this as 4 times cosine of 5 pi over 6 plus I sine of 5 pi over 6. It's going to be 4 times, let's see, make sure I'm in degree mode or radian mode. Let's see, cosine 5 pi divided by 6 gives me the decimal negative 3.46. And then we do 4 times sine of 5 times pi divided by 6. We're going to have 2i. So to graph that one, it's going to be, let's see, 1, 2, 3, 4, 1, 2, so right about there. And then let's do for 2 times cosine of pi plus I sine of pi. That's going to be, well, cosine of pi is negative 1, so it's negative 2. Sine of pi is 0 plus 0i, so it's just negative 2. And that's it right there. Now we're going to multiply these, and multiplying them, nicely it's already in this form, trigonometric form. So we just multiply those two magnitudes. So if we do 4 times cosine 5 pi over 6 plus I sine 5 pi over 6 times 2 times cosine pi plus I sine of pi, what do we get? 4 times 2 is 8 times cosine of 5 pi over 6 plus pi plus I sine of 5 pi over 6 plus pi. So it's 8 times what? Cosine of, that's going to be 5 pi over 6 plus 6 pi over 6 basically, so that's going to be 11 pi over 6 plus I sine of 11 pi over 6. And if it helps to work this out, we can do that. That's going to be, cosine 11 pi over 6 is square root of 3 over 2. And it's positive in this quadrant here. So 8 times cosine 11 pi divided by 6, 6.93 plus sine 11 pi over 6 is negative 1/2. 8 times negative 1/2 is 4, negative 4. Somebody say minus 4. I. So this will be over here at, let's see, 1, 2, 3, 4, 5, 6, 7. The scale is not quite the same. 1, 2, 3, 4. So I'd say somewhere down here. Okay, and I went ahead and labeled these A, B, and C, A, B, and C. So our last problem is 65, I believe. Yeah. Okay, so 65 says find the fourth roots of negative 1. Okay. And so this is going to be interesting. First of all, let's think about negative 1. And negative 1 would be just right here. There's no height to it. There's no imaginary part. And so the magnitude of negative 1 is going to be the square root of negative 1 squared plus 0 squared, square root of 1 plus 0, square root of 1, which is 1. And what is our angle on that? The angle is pi. So if we put this in the Euler's format, it'd be e to the, make sure I get this notation right, I think it's e to the pi I. Yeah. E to the pi I. Okay, so we're going to do the, yeah, there it is, E is magnitude of Z, E to the pi theta, good. Okay, so I want to have that down right, so I'm going to go for the Ronxian, is that what we're calling it in this book? Find the root W sub k. W sub k is going to be the magnitude of Z to the 1 over n power, e to the I of theta plus 2k pi over n. Okay. The first part's really easy to get because when we say, okay, 1 to the 1 over 1 is just 1. 1 to the 1 over 2 is still 1. 1 to the 1 over 3 is still 1. And 1 to the 1 over 4, oh, that's still 1. Then we're dealing with this e to the I theta. Theta is pi. So it's going to be e to the I times pi plus 2 times k is 1 for the first one. Or I think we start with 0. Start with 0. Should back these. I'll just do it here, fudge it here. The 0 is still 1. Okay. E to the I this is for k equals 0. E to the I times pi plus 2 times 0 times pi over 4, because you're in the fourth root. Okay, I just saw a mistake. These are all 1/4, I'm sorry. 1/4, 1/4, 1/4, so I don't need all those. So our w sub 0 is going to be 1 times e to the I times, now it's pi plus basically 0 over 4, so pi over 4. Our w1 is going to be 1 times e to the I times pi plus 2 times 1 times pi all over 4. And that's just going to be e to the I times what? Pi plus 2 pi is 3 pi, so it's 3 pi over 4. Our w2 is going to be 1 times e to the I times pi plus 2 times 2 times pi all over 4. That's just going to be e to the I times what? Pi plus 4 pi, 4 pi is 5 pi over 4. And our w3 is going to be 1 times e to the I times pi plus 2 times 3 times pi all over 4 there. It's e to the I times what? 7 pi over 4. So our solutions here, the roots, the fourth root of -1 is going to be, we have first of all e to the I pi over 4, e to the I 3 pi over 4, e to the I 5 pi over 4, e to the I 7 pi over 4. And that should do it for that one. Yep. Okay, I hope that makes sense. And let me know if you have more questions. Thanks.